Hello, this is section 8.8 complex numbers. Square root of a negative number. In practice, we are working with real numbers and we say that the square root of a negative number has no real solution. In order to work with square roots of negative numbers, we introduce an imaginary number defined as I, which is equal to the square root of negative 1. In practice, we write the square root of negative c as I square root of c. Example 1, rewrite the following expressions in term of I. So the square root of 36 is normally 6, so the square root of negative 36 is 6i. The square root of negative 16/25 will be 4/5 I. Now here we get the square root of 48 over the square root of negative 3, which first it would be I square root of 48 over I square root of 3. You might be tempted to reduce the negative 48 and negative 3, and that normally does not work. In this case, I think it would give you the correct answer, but normally it does not. But now you can cancel the i's out, and then this becomes the square root of 48 over 3, which is the square root of 16, which is 4. After rewriting negative square roots in terms of I, we can perform operations with the expressions. Perform the following operations and simplify your answers. Well, this becomes 3i plus 7i, and we treat the I like terms, so that'll become 10i. Square root of negative 15 times square root of negative 15. Well, I can think of this as the square root of negative 15 squared, which is then negative 15. That only works if the radicands are exactly the same. So normally what you would do is you would do I square root of 15 times I square root of 15, which then becomes I squared square root of 225, because that's what 15 times 15 is. I squared, then we have to think, well, if I is the square root of negative 1, then I squared would be the square of that, so negative 1. So this becomes negative 1 times, and the square root of 225 is 15, and you get negative 15. So you see you get the same answer either way, but notice if you would have did this as the square root of negative 15 times negative 15, which we did do this earlier in this chapter, that would be the square root of 225, which is 15, because a negative times a negative is positive, the square root of a positive is positive. So that's why when you multiply square roots, you can only combine them if they're both positive. This does not work when they're negative. C. Square root of negative 32 minus 2 square root of 2. So the first thing I'm going to do is pull an I out. So it's I square root of 32 minus 2 square root of 2. And now I can do the square root of 2 like I normally would with a factor tree. So 32, which is 4 and 8, which is 2 and 2, which is 4 and 2, which is 2 and 2. So that becomes I square root of 2 squared times 2 squared times 2 minus 2 square root of 2, which then becomes 2 times 2i square root of 2 minus 2 square root of 2, which then becomes 4i square root of 2 minus 2 square root of 2. Part D, square root of negative 5 times the square root of negative 45 minus the square root of negative 4. First thing we're going to do is take all the i's out, so it's I square root of 5, um, I square root of 45, and then minus 2i. Now I'm going to distribute we get I squared square root of 25 minus 2I squared square root of 5. From part B, we know I squared is negative 1, so this is negative 1 times the square root of 225, which is 15, minus 2 times negative 1 square root of 5, which is negative 15, plus 2 square root of 5. Number of the form a plus bi, where a and b are real numbers, is called a complex number. The real number a is called the real part of the complex number, and the number bi is called the imaginary part. If b is not equal to 0, then a plus bi is imaginary. If b is, sorry, I read that wrong. If b is equal to 0, then a plus bi is real. If b is not equal to 0, then a plus bi is complex. If a equals 0, then a plus bi is imaginary. Note, a number cannot be both real and imaginary. We say that two imaginary numbers are equal if the real and imaginary parts are equal. Find the values of x and y such that 3x minus the square root of negative 25 equals negative 6 plus 3yi. Well, the first thing I'm going to do is the square root of negative 25 is 5i, so we get 3x minus 5i equals negative 6 plus 3yi. Well, now the real parts, which are 3x and negative 6, have to be equal to each other. And the imaginary parts, which are negative 5 and 3y, have to be equal to each other. So now I can solve these two separate equations. Divide by 3, divide by 3. I get x is equal to negative 2. Divide by 3, divide by 3. I get y is equal to negative 5/3. Determine if the square root of 9 plus the square root of negative 48 and 3 minus 4 square root of 3i are equal. Well, I'm going to start with the bigger numbered one and see if I can simplify it to look like the smaller number one. So square root of 9 plus square root of negative 48, well, that'll be 3 plus I square root of 48. And now 48, I'm going to do a factor tree for. And I get 3 plus I square root of 2 squared times 2 squared times 3, which is 3 plus I times 2 square root of 3, which is 3 plus 4i square root of 3. So you can see these are not the same thing. They're not equal. One has a plus and one has a minus. And that'll be part 1 of section 8.8.